Hello everyone, welcome once again to our YouTube channel. Today we'll be describing or we'll be developing the eye. Remember the last video that we did is that we developed the ear, so maybe take a point before you watch the development of the eye, or maybe after the video, you go and watch the development of the ear. So we've covered, given the fact that we've done now development of the limbs, development of the ear, and development of other structures and the exoskeleton. So today we'd like to develop um, the eye. So, and how does it go across? So at this point, we are going to develop the eye by starting with the formation of the optic and the lens vesicles. So the optic and the lens, the first thing to form is actually the optic vesicle. So how does the optic vesicle develop? On around day 22, a pair of shallow grooves appear on this prosencephalon on either side. Remember, for the development of the ear, these shallow grooves, the optic vesicles, were actually occurring on the level of rhombencephalon. So the difference between this and the ear is that the eye develops on the level of prosencephalon, then the ear develops on the level of rhombencephalon. And actually that you can observe at this point. So this is the forebrain, the prosencephalon. Then these are the shallow grooves on the level of prosencephalon. Now, which will become at this point the optic vesicles. So closure of the mirror tube makes these grooves to form outpocketings called the optic vesicles. So now this encephalon has already closed, it gives you the optic vesicles, as you can see here. So this is actually at the level of prosencephalon, this is surface ectoderm, and then you have the optic vesicle now developing from the prosencephalon. They grow, they grow, and then they come into contact with the surface ectoderm. So we're now actually talking about the optic vesicle. When they grow towards, remember they are growing towards the surface ectoderm. So when they get into contact with the surface ectoderm, they induce this surface ectoderm to form, first of all, they induce it and then make it to elongate to form the lens placode. So you want to form the lens vesicle. So before you form the lens vesicle, what happens is that you'll have, first of all, having the lens placode. Then the lens placode invaginates to give you the lens pit. The lens pit, after further invagination, will give you the lens spool, and then the lens spool will actually detach from the surface that will become the lens vesicle. So actually, you induce me, I induce you. So you'll have the optic vesicle inducing the surface ectoderm to form the lens vesicle. Then the lens vesicle now will induce this optic vesicle to actually invaginate as we see here as we talk in the next slide. But before then is that the lens placode invaginates to form first of all the lens pit, then the lens spool, then after that you have now detachment to form the lens vesicle. It will detach. This lens vesicle detaches from the surface ectoderm now to become the lens vesicle. So that's the formation of the optic vesicle and the lens vesicle. I hope that tries to summarize everything. For the next slide, we'll be talking about is that we'll be talking about the optic cup, and this optic cup will be coming from the optic vesicle. So this optic vesicle will invaginate due to an induction from the lens, from the surface ectoderm of the lens vesicle to form a double-walled optic cup, as we can see here. So we had an optic vesicle which was attached to prosencephalon. So it invaginates to form a dual layer, to form a double-walled optic cup. So what happened is that on the lower aspect, on the inferior aspect and the central portion is where now the invagination occurs of the central portion and the inferior portion, leading to formation of a choroid fissure. This is a choroid fissure, given that the invagination was happening inferiorly and then centrally. That's the position of the choroid fissure. And then this choroid fissure, as you can see it here. So you have an optic vesicle, is a transverse cross-section, you have an outer layer, an inner layer, and a hyaloid artery at the center. And then this hyaloid artery is housed by this choroid fissure. And actually talk about this choroid fissure, housing the hyaloid artery, which supplies the developing optic cup. So the stem of the optic cup is called the optic stalk, and then this optic stalk is what that become the feature, the optic nerve. The fissure allows hyaloid artery reaching the inner chambers of the eye, of course, to supply it, supposed to disappear, but if it doesn't disappear, we'll see an anomaly on it, as we can see it here. So this is a fissure, this is the optic stalk, this is the optic cup with the invagination, and then you can see it has an outer layer and an inner layer. And then this outer and inner layer have an intraretinal space, of course, which is supposed to disappear. You can appreciate this is the whole of the brain, the prosencephalon at this point. So the layers, inner and outer layers, are separated by this intraretinal space I had alluded earlier, and then of which now this intraretinal space is supposed to disappear, and the two layers are posed attached to one another to give us one definitive layer. So maybe I had something that this optic cup, given that it's coming from a neural part, will give us a neural components in the eye. So you talk about the retina. This is a retina. Remember, the eye has three tunics. It has an outer fibrous, inner middle vascular, and an outer neural one. So we talk about the retina. So the retina is actually this one in yellow. You can see it here. This is now the hyaloid artery that is now obliterating, as you can see. The developing eye. You can appreciate this is a lens, developing lens, is a developing cornea. Actually, you can appreciate this is the iridopapillary membrane. This is a vitreous humor. You can appreciate now the various tunics being there. You can see the iris and the other parts being formed. So the retina comes from the optic cup. So remember, the optic cup had two layers. The outer layer gives us the pigment retina, or the retinal pigment epithelium, and then the inner layer is the one that now becomes the neural retina. So for this neural layer, or the inner layer, is that we have the posterior part, posterior 4 or 5, form the pars optica retinae. So the posterior 4 or 5 of this neural layer forms the pars optica retinae, of which now it will differentiate to give us the layer of photoreceptors, cones, and neurons. Remember, the posterior part of the eye is the one that has cones and rods. So from here to here, that is where you have the retina with the rods and cones. So that is a pars optica retinae. Then the adjacent layer forms the neurons. The adjacent layer that is now around this place will form mantle layer that forms the neurons and supporting cells. So that the outer nuclear, inner nuclear, and the ganglion cell layer. That is the adjacent mantle layer. Adjacent mantle layer. And then the outer layer now, the outer layer at these points will give us now the optic nerve. So here you have the neural layer. You have the neural layer, and then you have the pigment layer. You can appreciate the pigment layer is in black. Then the remaining layers is actually the neural layer. So at this point, this is a posterior 2 or 4 or 5. You will form the layers of cones and rods. Then just adjacent to it, we have the mantle layer. This mantle layer will give us the outer nuclear, inner nuclear, and the ganglion layers. And then now this most outer layer, this outer fibrous layer will give us the axons of the nerves that come and form the optic nerve. So maybe I can take us back to the histology of the eye. So we can go and watch the video on the histology of the eye on the level on the histology of the 10 layers of the retina and how you can be able to arrange them from layer number 1 to layer number 10 histologically for our understanding. So remember we had a layer between the outer and the inner layer, so between the pigment retina and the neural retina, and then this intraretinal space obliterates. This optic stalk, which was being formed by the axons of the outer fibrous layer of the neural layer, will form the optic stalk. So this optic stalk gives us the optic nerve. So that's the retina. For the iris, remember we are talking about the posterior part giving us the retina. So the anterior part will give us the iris. So the iris is formed from the outer layer anteriorly from the pigment layer of the iris. So the outer layer of the cup, outer layer of the optic cup anteriorly. So remember from here, there will forming the retina. Now, anteriorly at this point, the pigmented epithelium of the retina, of the iris, comes from the outer layer of the cup. Then the inner layer of the cup at this point, we can appreciate it come from various components. It will come from various components. So the iris at this point has pigmented epithelium, as we know histologically. So the inner layer of the cup develops from optic retinae, which divides into pars iridica retinae. So this is the point where you talk about the optic retinae. And then this optic retinae, it will divide into pars iridica. Pars iridica means the iris part of the retina, the anterior part of the neural layer is actually now the inner layer of the iris, and then the pars ciliaris retinae. This ciliaris retinae is all that now will form the ciliary body. So remember the ciliary body is here, which is formed from the pars ciliaris retinae, ideally the ciliary part of the neural layer. And then the pars iridica retina is the iris part of this optica retinae. So that's just worth that, just making us to understand more. So we have an outer layer giving us a pigmented layer. Then the inner layer is being formed, or inner layer of the cup forms the pars iridica retinae and the pars ciliaris retinae. So remember, this inner layer of the cup is also known as optica retinae. So this pars optica retinae divides into two, pars iridica and pars ciliaris. So this pars ciliaris forms the ciliary body. Then the pars iridica retinae forms now the inner layer of the iris. I hope that makes sense. And then now just to finalize that, we'll have the surface ectoderm giving us now some of the muscles of the iris. As you can appreciate it here, we have the sphincter pupillae. See the sphincter pupillae and some of the ciliary muscles and the dilator pupillae muscles. So the sphincter pupillae and the dilator pupillae muscles are formed in the loose mesenchyme between the surface ectoderm and optic cup from the ectoderm of the optic cup. So sphincter and dilator pupillae are actually muscles of the iris. So remember the sphincter pupillae, they decrease the size of the pupil. Dilator pupillae increase the size, dilation of the pupil. So these are the muscles that are formed in the loose mesenchyme. Remember our mesenchyme between the iris, developing iris, or the develop from the optic cup and the ectoderm, surface ectoderm. So those muscles will be formed from the ectoderm of the optic. I hope that tries to make sense. And then you can see these muscles here are the sphincter pupillae and the dilator pupillae. So they actually the two muscles that actually come from the surface ectoderm. Then maybe to finalize that the pars ciliaris retinae that is highly folded. So this is the one that was giving us ciliary process. The pars ciliaris retinae becomes highly folded to give us the ciliary body and the ciliary muscles. Yes. So the mesenchyme that is just below it will give us the ciliary muscles, and then the ciliary processes becomes highly folded for the purposes of the iris. So we now form the lens. Remember the lens we had formed already the lens vesicle from the induction from the optic vesicle. So we had the lens placode, lens pit, lens spoke, then the lens vesicle. So we had talked about this earlier. So I won't allude much to that. But before that, we need to know that the cells of the posterior wall. So this is the lens vesicle. So the cells of the posterior wall will elongate anteriorly. So this is a one that will elongate anteriorly and form long fibers that gradually fill the lumen of the lens vesicle, as you can appreciate here. So these are the cells that are elongating anteriorly to fill up this space. When they fill up the space now, another important thing happens. In the second week, the primary lens fibers, these primary lens fibers will reach at the anterior portion, the anterior wall. But now with time, the secondary fibers that are coming from the posterior portion are added to the central core. as you can see at this point. So they're coming from posterior end and they're added to the central core. And by that version now, you'll already have formed your lens. So remember, this lens has various compounds. It has fibers, it has glycogen, and they are arranged in a certain fashion. So that is how the lens is formed at this point. So you have the lens, you have induction by the optic vesicle, you have the lens placard, the lens pit, the lens pore, then you have the lens vesicle, then the cells from the posterior end elongate anteriorly. After they elongate anteriorly, they reach around the second week, they reach on the anterior. Then the cells from the posterior end now, also now to give you the secondary fibers, they are added to the central or to give us a definitive lens. For the choroid, sclera, and the cornea, remember that is this now. At this point, we'll be talking about the vascular layers, the other tunics. So we can appreciate that they will be coming from the mesenchyme that is just surrounding it. So we have the choroid, which is the middle vascular layer, and then the sclera that is outside, actually the fibrous layer. So the eye primordium is covered by a loose mesenchyme, as you can see here. So this is a mesenchyme that is covering this optic cup, the eye primordium. So this loose mesenchyme will differentiate into an inner vascular, this is inner vascular, and an outer fibrous. This inner vascular part giving us the choroid, and then the outer fibrous part, which is now will give us the sclera. So the inner vascular layer gives us the choroid, and the outer fibrous layer gives us the sclera segmentation. So we've already formed now the three tunics. We've already formed the retina, the choroid, and also now the sclera. So those are the how we form those layers from loose mesenchyme. Now, what about the cornea specifically? So cornea is the one that is just anterior. So there is a cornea. So remember, there is some mesenchyme that is in between the developing iris, the lens, and also the surface ectoderm. So we have this mesenchyme here. So we have a mesenchyme in between the lens and the iris, and also the surface ectoderm. So mesenchyme in front of the lens and the iris and the surface ectoderm forms the anterior chamber. So this is the anterior chamber here. As you can appreciate, this is the anterior chamber. This anterior chamber, sorry, as you can appreciate, this is the anterior chamber. So the mesenchyme undergoes vascularization to split into two. So this mesenchyme will undergo vascularization to create a space. So when you create a space in between at this point, we are differentiating the cornea, iris, and the lens. But the membrane will remain. And this membrane is the inner iridopupillary membrane. And then on the outer part, we'll have the cornea. So you had the mesenchyme here. This mesenchyme undergoes vascularization to create a space. Now, posteriorly, we'll create this iridopupillary membrane that now will be lining the iris and the lens. And then anteriorly, we'll be having the cornea that is now just next to the surface. So this is a cornea. So the mesenchyme undergoes vascularization to split into inner iridopupillary membrane, which disappears, it's supposed to disappear. And if it doesn't disappear, you have an anomaly. And the outer substantia propria of the cornea. So this is an anterior chamber which is lined by flattened mesenchymal cells, which forms now a layer of the cornea of the cornea. And hence the cornea is formed by epithelium from the surface ectoderm. This epithelium from surface ectoderm, substantia propria, and epithelium from the mesenchyme bordering the anterior chamber. So at this point, remember the cornea has 5 layers. So we already formed the anterior layer, epithelium from surface ectoderm, the substantia propria from the mesenchyme, and posteriorly we'll be having now this epithelium from mesenchyme that is bordering now the anterior chamber. Remember this anterior chamber. Then where do the other 5 layers come from? The other 2 layers at this point will be coming from, remember we have the basement membrane and the porous membrane giving you now the definitive 5 layers of the cornea. So those other layers will be coming as layers in between the epithelium and the substantia propria. So anterior, you have an anterior layer between the epithelium, a membrane between the anterior epithelium and the substantia propria. And then posterior, you also have now the desmal membrane between the substantia propria and the posterior epithelium, which is now just anterior to the anterior chamber. And that's how you have all the definitive 5 layers of the cornea. Remember, you have this inner iridopupillary membrane supposed to disappear. If it doesn't disappear, you'll see an anomaly in a few minutes. So actually, we've come to the anomalies, and the anomalies is that you can have cyclopia. So cyclopia is when you have one eye. Synophthalmia, when you have fused eyes. Anophthalmia, absence of the maybe one of the eyes, or completely absence of all the eyes. Microphthalmia, reduced size of the eye or diminished eye. Congenital cataracts. You'll see congenital cataracts in a few minutes. Coloboma. So congenital cataracts has an issue to do with the lens or the cornea. Coloboma, this now an issue to do with the iris due to persistent choroid fissure. Retinal herniation of the retina. Persistent hyaloid artery. Now, if this hyaloid artery that we talked about earlier, if it doesn't disappear, you can have persistent hyaloid artery. You can have congenital aniridia, absence of the iris. Congenital aphakia, absence of the lens. And then persistent iridopupillary membrane or the web-like eye. So this iridopupillary membrane is just attached to the lens and the iris. So that's the reason I think web-like. Yes, I remember for us to like, comment, share, and subscribe to the YouTube channel for more. But let's see these anomalies. So the first anomaly that we're seeing here on our left side on the upper row is actually this is coloboma. Then we have persistent iridopupillary membrane, as you can appreciate here. Then on this other end, on the lower aspect, this is congenital cataracts. Congenital cataracts. This image, as you can see here, this is persistent hyaloid artery. If it doesn't disappear, if it doesn't obliterate, you have persistent hyaloid artery. Then you can see here is actually a small eye. You can appreciate here. At this point, this is microphthalmia. Then you can appreciate this beautiful kid, beautiful child at this point has congenital aniridia, as you can see there. Then this is microphthalmia. You can see microphthalmia, congenital aniridia, but now not the whole of the iris is missing actually. Not that the whole of the iris is missing because it's there, but now this end is actually missing congenital aniridia. Same case on this one is congenital aniridia. Is congenital aniridia. At this point, we have a case of anophthalmia, absence of the eye completely. So the eye is missing, congenital anophthalmia. This anophthalmia. And then actually this slide is now showing us congenital absence of the lens. This one is congenital aphakia. Congenital aphakia. Then we have synophthalmia, suffused eyes. You can see fused eyes. So this one is an issue to do with the signaling of the optic vesicles to divide, as you can see here. So they are formed on the same field. The optic field doesn't divide into two. You just have one optic field. Yeah, same case with cyclopias. At this point, you can see the optic field didn't divide into two. And then this is microphthalmia, complete. This is microphthalmia, anophthalmia, microphthalmia, anophthalmia, synophthalmia, cyclopia, congenital aniridia. Congenital aniridia. This is congenital aphakia, congenital aphakia, microphthalmia, anophthalmia, synophthalmia, cyclopia, congenital aniridia, microphthalmia, persistent hyaloid artery, microphthalmia, congenital aniridia, congenital cataracts. At this point, you can see persistent iridopupillary membrane, persistent iridopupillary membrane, and then you can appreciate this is coloboma. It's correct fissure. persisted at this point. And then maybe to finalize that the ear tends to be lazy, it craves the familiar and is shocked by the unexpected. But the eye, on the other hand, tends to be impatient, craves the novel, and is spoiled by reputation. So at this point, maybe to wrap it up is that I have nothing other, anything else other than thank you. Maybe just to encourage us with that visual nine. That have I not commanded you, be strong and courageous, not be afraid, do not be discouraged, for the Lord your God will be with you forever. You go as long as we just keep committed. As long as we just keep committed. So with that, I wish you all the best. Can you like, comment, share, and subscribe? And I'm looking forward to seeing you in the next video. Have a blessed time.